All right, guys, we're back with the second video for this section. So we've read the article and watched the video now. So now let's look at the diagram they have here. So in our diagram, you can click on it to make it bigger because I know my old lady eyes could definitely not see that well. It shows us a comparison, right? The diameter of Earth to Mars, shows us what the inner cores look like. And we have a caption here, right? We have a text feature. Since Mars lacks magnetic field, scientists believe it does not have a rotating liquid metal core like Earth. So we have this liquid metal core. This could explain why the diameter of Mars is half that of Earth, yet its mass is 1/10 of Earth's mass. So it is smaller in diameter because it's missing that core, but also that liquid metal core holds a lot of weight, right? So that's a lot of mass that Mars would not have. You could also click on the chart here and click on that to enlarge it. Here we have comparison between Earth and Mars gravity, weight, length of their days, years. You can see this year is almost twice as long, but the day is only a couple minutes longer. Average temperature range, we can see we go from -27 to 136, much colder at Mars, right? -194, which I mentioned that Mars can get much colder. The distance from the sun and the number of moons, comparison there. And you also have a photo. This photo compares, shows us Olympus Mons compared to the state of Arizona. The caption here says it's the largest of the known mountains in our solar system. With a diameter of 374 miles, it's approximately the same size as the state of Arizona and is a whopping 16 miles high. This mountain is actually the size of one of our entire states. So we have a photo comparison there. After you've reviewed all those, click Next. What conclusion can be drawn about how Mars became known as the red planet? Was it the fire from all its active volcanoes making the planet look red in the night sky? Does it look red in the night sky because of all the red, rusty iron in its atmosphere? The surface of Mars is actually red, so people have always referred to it as the red planet. The Latin word Mars means red, making it an obvious nickname for the planet. Well, neither in the article nor in the video did I see anything about this Latin word meaning red making its nickname. If we wanted to go back, remember the video was most helpful for determining is Mars really red. And remember they talked about a bicycle and how it rusts and how that rust color is coming off of Mars into the atmosphere, making it appear red when actually it's more of a butterscotch, like the article stated. So it's not active volcanoes. The only volcanic activity we really talked about was related to that mountain. It didn't say that there's like all these active volcanoes, with lava. The only thing they mentioned was the red, rusty iron that's coming off of the planet and is going into its atmosphere, giving it that red color when in fact it's butterscotch. Click Next. What additional information does a video provide that's not included in the text? So what is in the video that is not in the text over here? There are a lot of different colors on Mars depending on what mineral deposits are on the surface. When mineral deposits are exposed to the air, they oxidize, much like a bicycle that rusts from sitting outdoors. I do remember that example being in the video where they had a bicycle outside. The air kicks up rusty dust particles and makes the planets look the color of the mineral. That's true too, right? They kicked up all those rusty dust particles, or all of the above. And they also mentioned that it could be different colors based on what mineral deposits are on there. So in this case, I think our best option is going to be all of the above. The video did mention those things. The article didn't go very in depth, other than to say that if we got to know a little bit better, we might not call it the red planet. And in the video, we did get to know a little bit better. And it's all of the above. What information from the text is not supported by the data on the chart? So, each day on Mars is slightly longer than each day on Earth. So they said that in the text. I'm going to look at the chart. Is each day on Mars slightly longer than Earth? Each day, 24 hours, 37 minutes. That is a little bit longer than 23 hours, 56 minutes. So that's true. A year on Mars is almost twice as long as on Earth. Let's look. A year on Mars, well, Earth is 365, Mars is 687. That's about twice as long. Mars' lowest average temperature is much colder than Earth. They said that in the article, and let's look at our chart here. Lowest average is negative 27. Lowest average is negative 194. The air on Mars is 100 times thinner than Earth's. Well, they don't really talk about the thinness of the air on our chart. I know they talked about the thinness of the air in the article, but let's look and see. I see gravity, weight, length, temperature, nothing about the thinness of the air. So that's not included in our chart. Click next. I don't know why my video cut out, but you can still hear me. So we're going to finish this one up. What additional information does a chart provide that the text does not include? So Mars is colder than Earth. See, mention that over here on our chart, right? Mars temperature going to negative 194. Let's look back here and see if they also mention, yep, lowest average temperature is much colder, so that's in both. There's less gravity on Mars than on Earth. Let's see, that is on our chart here, right? The gravity on our chart is 12. On Earth, it's 32. Let's look in our article and see if they mention gravity. I see the length of the days and years, temperature, thinner atmosphere. I don't see anything about gravity. Mars is farther from the sun than Earth. We have the distance from the sun in our chart. Do they mention the distance from the sun in our article? Yes, it talks about the orbit length being further and that it's, yep, got that there. Gravity relates to weight. Well, we have gravity and weight discussed in both of these as well. So the only thing that they don't talk about in both of them is that there's less gravity on Mars than on Earth. They don't talk about that in our article, but they do add that onto the chart. What conclusion can be drawn from both sources about the size and weight differences between Earth and Mars? Well, what is causing the difference in size and weight? Remember, we were looking at this chart here, this diagram, we were seeing this one had that liquid middle, right? That inner core. I was making middle and inner one word. So it had that liquid inner core that Mars doesn't have, right? Made of metal. Is it probably smaller and lighter because it's farther from the sun? It's half the size of Earth because there's no water on Mars. They never mention that. Mars is probably smaller and lighter because it lacks a liquid metal core. We talked about that liquid metal core here, and it says it could explain the diameter being smaller and it being 1/10 of the mass. Mars has 1/10 the mass of Earth because there's less gravity on Mars. Well, this chart's saying that it might not be because of that, right? It's because of that metal liquid core, which I also talked about in the article over here, that it's much smaller and lighter. Right? Smaller and lighter. And that we have the liquid metal core here, adding that weight and that size. So Mars is smaller because it doesn't have that liquid metal core. Click next. What conclusion can be drawn about the landforms on Earth and on Mars? So those landforms like Olympus Mons, right, and Mariner Valley and the Grand Canyon. What can we tell about those? Like Olympus Mons, Mount Everest is a mountain formed by a volcano. A few landforms are much larger on Mars than on Earth. Like Mariner Valley, the Grand Canyon is as wide as the continental United States. Well, we know that's not true either. The Grand Canyon is not as wide as the entire United States. Remember, it's located in the west of the United States. A few landforms are much older on Mars than on Earth, but we didn't talk about the age of the landforms, really. We talked about a couple different landforms, being Mariner Valley, the Grand Canyon, and Olympus Mons being much larger than landforms that we have here that are similar, but smaller in size. So we can conclude that there's a couple landforms there that are a lot bigger than ones that we have here. All right, and that was your last question. If you have any other questions, please reach out to your classroom teachers or myself or Ms. Bachelor, and we're happy to help you. Have a good day, guys.